Welcome back. Now we go over problems from WebWork in section 8.2. Problem 1. Find the area of the surface obtained by rotating the curve y equals x cubed by 6 plus 1 by 2x, where x is between half and 1. You want to take this curve and rotate it about the x-axis. So the picture is as follows, right? Fx is x cubed by 6 plus 1 over 2x. So derivative is x squared by 2 minus 1 over 2x squared. Take common denominator of 2x squared, you get x to the fourth minus 1. Square root of 1 plus f prime x squared is square root of 1 plus x fourth minus 1 over 2x squared quantity squared. When you take square this expression and take common denominator, you get 4x to the fourth as a denominator times 1 is 4x to the fourth plus. This is a complete square, so x to the eighth minus 2x to the fourth plus 1. Simplifying or combining like terms, you get x to the eighth plus 2x to the fourth plus 1 over 2x squared squared. Square root of all this is x to the fourth plus 1 over 2x squared. Now, fx times square root 1 plus f prime x squared is your fx expression, and square root of 1 plus f prime x squared, its expression. Now, common denominator and then multiply. In the end, don't forget to divide this by distribution. So basically, this is the expression you get, and now you're ready to take the integration. Integration is from half to 1 to pi f square root of 1 plus f prime x squared. So 2 pi is a constant, I bring it out, half to 1 integral fx times square root 1 plus f prime x was this entire expression. Okay. Now this is standard integration. X to the 5 gives you x to the 6 over 6. With a 12, you have 72 here. Integral of x is x squared over 2. With a 3 there, it's a 6 here. This is x to the negative third, so negative 1 over 2, x to the negative 2, which amounts to all of this. Evaluating it all of this, assuming my calculations are correct, I'm going to substitute this as a solution. Do not forget 2 pi. Okay. First expression is 1 over 72 plus 1 over 6. So notice how I'm not even required to calculate. WebWork will calculate for me. 1 over 72 times 2 to the power 6 plus 1 over 6 times 2 to the power 2 minus 2 to the power 2 over 8. All right, let's check. Okay, it's correct. Next problem. Which of the following integrals represents the area of the surface obtained by rotating y equals e to the x about the y-axis? Y is between 1 and 2. All right. Y equals e to the x. You want to rotate the curve about the y-axis. Y equals e to the x looks like this, and you want to rotate it about the y-axis. So notice, if y is e to the x, x is natural log of y. Okay, and when x is between, when y is between 1 and 2, all right, when y is between 1 and 2, x is natural log of y. Now, dx dy is 1 over y. Notice we are rotating about the y-axis, okay? So 1 plus dx dy squared is 1 plus 1 over y squared. Oh, sorry, dx dy is 1 over y, dx dy squared is, yes, this is correct. So now this is y squared plus 1 over y squared. So the surface area is, I'm taking derivative with respect to y, so limits of y apply, and this is x. X is the x direction, so that's the radius times square root 1 plus dx dy quantity squared. X itself is natural log y. All right, so you have your expression. This is the expression you're looking for. So let's see whether any of these expressions show up. Integral 1 to 2, 2 pi is there. Natural log y, 1 over, oh, so that's already the very first expression, I believe. Okay, so let's check. That's correct. Next problem. Find the area of the surface obtained by rotating y equals cosine hyperbolic x about the x-axis, x being 0 to 1. X being 0 to 1 about the x-axis. Standard material, fx is cosine hyperbolic, so 1 plus f prime x. Derivative of cosine hyperbolic is sine hyperbolic. So 1 plus f prime x squared is 1 plus sine hyperbolic squared. That is by identity cosine hyperbolic squared. So square root of this quantity is back to cosine hyperbolic. So 2 pi fx square root 1 plus f prime x squared is 2 pi cosine hyperbolic times cosine hyperbolic. Cosine hyperbolic is e to the x plus e to the negative x over 2. Its square is e to the 2x plus 2 plus e to the negative 2x all over 4. Now reduce the 2, you get pi times e to the 2x plus 2 plus e to the negative 2x, the whole over 2. So required surface area is integral 0 to 1 2 pi fx square root 1 plus f prime x squared dx. This expression is just out here, so I'm writing it here along with the 2 pi. You see, where did it go? Yeah, along with the 2 pi. So all of that, pi over 2 is a constant. When you take integral of these are standard integrations. Integral of e to the x is e to the 2x over 2. Integral of 2 is 2x, e to the negative 2x, its integral is e to the negative 2x over negative 2. So that positive became a negative. Limits of integration are 0 to 1, and this is the expression we have. Notice half minus half, they cancel. So this is all I need, right? Pi over 2 times this quantity. Let's try. That's correct. Next.